Welcome back to our numerical analysis series. In today's video, we are diving into one of the most powerful root finding technique, that is the Newton-Raphson method. So buckle up as we visually explore how this iterative method zooms into the root of a nonlinear equation. So let's understand the Newton-Raphson method with this graphical representation. So we are going to draw our x and y axis with the help of a scale. This is our y axis and this is our x-axis. Here we have x-axis and here we have y-axis. And we are given with some function. So we are given a function y is equals to f of x, and we want to find the root, the values of x for which f of x is exactly equals to 0. But as we are going through the numerical analysis course, so in numerical analysis, we are not able to get exactly equals to 0, but approximately equals to 0. So we start with our initial guess. So here we have an initial guess that is P naught, that is basically somewhere here. So the point corresponding to this is P naught and f of P naught on the curve. Now we are going to draw a tangent line. Again, we use a scale here. And we just like this. So we draw a tangent line to the curve at this point, and the slope of the tangent line is the derivative of the function at P naught, and that is denoted by f prime P naught, and we call it slope. So the idea is to follow the tangent line until it intersects the x-axis, and the x coordinate is your next approximation. So we call it P1. It lies somewhere here. So mathematically, it is given that P1 is equals to P naught minus f of P naught divided by f prime of P naught. Now we repeat the same process at P1 and we plot P1 f of P1 by drawing a tangent line. So this is our new tangent line we are going to draw here. So it touches at this point and we call it P2. This point is even closer to the actual root. As you can see, with each iteration P0 to P1 and P1 to P2 and so on, we are getting closer and closer to the root of the function. This visual approach helps us see how Newton-Raphson method quickly convergent when the functions behave nicely. And that is the graphical beauty of the Newton-Raphson method, that is a powerful, fast and elegant. If this helps clear things up, give this a video a like and subscribe for more intuitive explanations. So in this next video, we will break down the working rule of the Newton-Raphson method step by step. So see you there. Take care.